Greetings, everyone, and welcome to the Blockchain Days Native Ethereum blockchain support in Cortex session by Edward Budniak. My name is Esther, and I'm going to be the host of this session. I will try my best to catch up with your questions that you may have throughout the session. So please feel free to put any notes, questions, or comments in the Q&A session. Edward requested us to interrupt him with questions on the spot. So you're more than welcome to share your ideas. The presentations will be recorded and later on made available on the Community Z portal. So I'm looking forward to your session, Edward. The stage is yours.
Thank you. Sorry, we have a little problem. So our camera is broken for a few seconds. I think it will be restored in a minute. In the meantime, I will start the presentation. One moment. Okay, I'll start sharing my screen.
Unfortunately, I still can see your frozen camera picture.
Yeah. So can you see my screen?
Now it's perfect. Thank you very much.
Oh, okay. You can see me. Yeah. So good morning, everyone. My name is Edward, and I'm the developer at the crypto department in EPAM RTC Lab, previously called Deltix, before we were bought. There's a slide about me. I'm worked and working under the crypto trading platform development for almost 3 years. Oh, yeah, the camera will boot in a minute. I'm a crypto fan. I'm curious about all the Centralized technologies. Even developed my own fan-made crypto with proof of work based on Tetris game called Coin. You can ask me about it if you want. So today I'm going to talk about the needs of trading platform in the crypto domain, current solution for them, pros, cons of them, and our own little research and experience we gained from it. One of the purposes, another one purpose of the talk is to show how simple it could be to add the crypto functionality to integrate with the Ethereum blockchain, for example, to your software, and what upsides and downsides you can get with this approach. Okay. That's all about me for now. Let's start with, it's just the content. Let's start about the products we're talking about, just a few words about it. So it's called Cryptocortex.
Recording in progress.
Oh, okay. Thank you. Got it. Okay. It's called Cryptocortex. This is a platform for a wide spectrum of assets which can act like an exchange, trading platform, tool for some internal transactions for the kind of big clients. It can act like a tool for arbitrage, and even in some configurations, it can act like an NFT trading platform. Okay. Yeah. As the number of configuration is enormous, we have spent a lot of time to create different services that can be integrated with the platform. It's pretty fast. It's based on location-free code heuristic algorithms and various modern memory and CPU optimization techniques. Also, Cryptocortex is used in giant product by giant clients, like, for example, TradeStation. It's billions of dollars clients. And then dozens of smaller products from Europe, from Asia, from America, from every point in the world. Okay. But today's lecture is about how the platform is tied with the crypto. And as I said before, Cryptocortex perform a lot of transactions, as you may think, as a trading platform. There are a lot of transactions. Withdrawal transactions, deposit transactions, and but how these transactions is handled? Cryptocortex is not part of the blockchain; it's not a centralized exchange. So how the users' assets are managed? Every platform must have some kind of wallet. some kind of wallet. Fiat asset management is beyond the scope of this presentation, but as you may have thought, the crypto exchange must have some way to interact with the crypto. For most platforms, for the most time, including the Cryptocortex, this can be achieved by using the third-party providers. And we will talk about them, about the sides and downs of using the third-party providers. So yeah, what the purposes of the providers is the function. What the functionality we need from providers is, first of all, observing transactions, securely storing assets, and creating transactions for cryptocurrencies and tokens. I think this camera broken again. Really sorry, there's some kind of issue we cannot handle right now. I will continue the presentation. Okay, let's continue. So the basic scheme, we will talk about what wallet manager is, but for now, you just must know that wallet manager is the part of Cryptocortex platform that's responsible for all deposits and withdrawals in the platform. It's connecting using, for example, a REST API with some third-party provider that provides us the functionality of the blockchain. So what are the third-party providers, what's the most popular ones, and what we have tried to use? There are a lot of them. What's the pros of using the third-party providers? It is extremely easy to integrate. You have no need to write a lot of codes. You can rely on the provider support, and you can trust provider security safety audits because they take a lot of them. And the volume of assets traded on the trading platform like Cryptocortex can be tremendous, though that can be hard to handle on your own. Also, using the providers, you have no need to integrate with dozens of blockchains, run dozens of nodes, and maintain the servers on your own. But there are some limitations and pitfalls in using providers. Let's look into some of them to define what I'm talking about right now. 1 second. Okay. First of all, it's BitGo. This was the first provider we integrated with. BitGo used to be the leader of multi-assets provider world. After using it for 3 years, we discovered a lot of problems that was caused by BitGo and could not be fixed from our sides and by any approach. First, it's of course fees. BitGo charges a fee on every transaction, on every address creation, and of course for the support. And you cannot reduce fees because you have no control of how BitGo operates internally. For example, every Ethereum address provided by BitGo is a smart contract. We will discuss what a smart contract is later, but for now, the important part is that while there's a safe way to concentrate assets in one place, it's expensive. And when the Ethereum price spikes at the end of 2020, every generated address would cost more than actual assets transferred to it. It used to be somewhere about $200-300 per address, which is not sustainable for any business. It's like robbery. And as you can imagine, every user may have a lot of Ethereum addresses for different purposes, for different needs. Second are the technical limits. Of course, there are a lot of limitations on the number of requests you can do. Requests like request the status of transaction, create transaction, do some authentication, and so on. They either and also there are limited number of assets types they support. Of course, you have no need to support every new coin, for example. But if you wanted to support something specific, for example, a client wants to create a new coin, and supported under their management on the Ethereum platform, you can do it. It's just a dead end. The provider either supports it or not, and it can take days or even infinity amount of time for them to do it. Also, this is the third issue, the third big issue. This is we had to put some trust in the provider and ensure that they have no access to assets stored in our wallet. But we can never be certain about it, or of what's when. Sorry. So we can't be certain about it in any time because we have no direct access to the wallets, to the servers, to the nodes. Okay. This was the first provider. The last but not the least, also about Bitcoin. The last but not the least is long-term maintainability. As I mentioned before, BitGo used to be the leader, and after some time they become complacent, they become lazy and unreliable in some ways, and some currency, especially in test environments, just accidentally stopped working, just randomly stopped working. There were a lot of bugs on the API on their site that didn't get fixed for years. And support response time had grown from something about 15 minutes to for an average to a month. And I think you can imagine what waiting for the entire month for a trading platform can do. Due to this change, BitGo has lost a large market share and is no longer a leader in. It's no longer a leading crypto provider. Okay, let's talk about the second one. The second provider we integrated with was Carve. Carve were much more reliable and fixed some problems that BitGo doesn't. But remember what I said about the number of request limitations. Carve has even more of them. For example, they allow you to perform no more than 18 HTTP requests per minute. For the entire platform. It's a very small number, and we will have to reduce the reliability of our platform and reduce the amount of information about the current transaction states to perform transaction like it were before. The ping is raised, the queries queue is giant, and as with BitGo, we cannot really do something about that. They just say that it's okay, it's just working for other clients and will work for you. But this is not. But to the Carve owner, they give you some freedom in asset management. You can add some custom tokens provided by the Ethereum that supports ERC20 standard, for example, and manage transaction in a better way. Which can reduce fees and improve the speed of the transactions. Just a little more about providers. There are a third provider we are currently integrating with. As you can see that the first two attempts were not kind of failure, but there were a lot of downside in it. Now we tried we integrating with the FireBlocks. FireBlocks is kind of a new leader of this market, claiming that they fixed major problems, such as such as the number of requests. They said you can do a lot of requests, such as asset management, security, and so on. And we'll see. This can be true, but as we can see, there are problems that couldn't be avoided completely while using the third-party provider. Here we at Deltix, before they pump waters, thought about the different way, about the third way. What if we could implement some of the needed functionality by ourselves and leave the rest to the providers? For example, we can support ERC20 token by ourselves. In the time when we implemented it, we used only BitGo. There were no Carve, so this was an actual. So that's why, and why? We have an experience in crypto and some developers, so why not to try? So we began the experiments. We want to support the custom Ethereum tokens, as I said, and we cannot do this using existing one solution at the time, is what we go. So I'll continue with a little bit of theory. Okay, 1 moment. So, conclusion for the third-party solutions. No need to write a code, no responsibility, no such big responsibility. No need to have your own support team. No need to maintain your own nodes, your own servers. But the cons are bigger from my side, from my point of view. You can add additional functionality. You can support a lot of assets. You have some trust problems because you can trust only yourself. It's extremely dangerous in terms of long-term support because, as I said, for example, BitGo, I don't know how they live right now because support just doesn't work, and it's kind of a problem. And it's very expensive, as I said, with BitGo. You should pay a lot of money for them to operate with your transactions. Okay, a bit of theory how the blockchain works. I know that the blockchain is in hype for at least 5 years, I think, from 2016, 17. But still, not a lot of people think about how it actually works. So let's step back and think about what interaction with blockchain looks like and how it works in the generic case. We have heard a lot about the crypto for the last several years, but unfortunately, only smart parts of crypto enthusiast community is really aware about how the cryptocurrencies and blockchain works on a technical level. Beyond the fact that the blockchain is some kind of distributed database with a math magic underneath. So what is a crypto blockchain or any other payment system in general? We can think about it as about a long list of transactions from one party to another. We can accomplish this in different ways, but the underlying logic here is the same. In case of Visa, for example, this list is stored and managed by the private company, Visa NC. And we are paying fees to them for this list, for the list management. As you can see in the slide, we can transfer our assets from there, for example, account 1 to the account 2 and pay some fee. For example, for Visa, you always pay a percentage of transaction, at least if you are physical. So yeah. Okay, let's continue. But in case of blockchain, the same list storage, the same list management is done by, the same process is performed by thousands of private computers that run special software, also called blockchain nodes. The first and the second system has its own downside and upsides. If we're talking about for example, fees on the blockchain, that's how, for example, this list looks in blockchain. I take the Ethereum when it costs $2,000 and $400. And as you can see, for example, for the Ethereum, every transaction costs you the same amount of money. But if the Ethereum costs a lot, and it's popular nowadays when the blockchain network is overloaded, the fee can be pretty big. And it can be expensive. But for for example, big transfers, it can be relatively cheap compared to the Visa. Okay, but why? So what is upsides of letting someone use your private computer for some asset management? The benefits of hosting nodes are the fees and the rewards that's given you by the network, by this decentralized network. Oh, sorry. Also about how the blockchain looks. The most entry-level crypto enthusiasts thought that the blockchain is some symmetrical, beautiful network when everyone is even, and it's so beautiful payments here and here. But actually, the blockchain network is kind of a mess. There is a lot of different nodes and different software, different computers, different speed. Some nodes want to observe on information, some want to perform the transactions, some want to manage the list and get the rewards. They are also called miners. So, yeah. Okay, let's continue. Some blockchains network have an additional functionality beyond handling transaction lists. The network, or more precisely, nodes, can also process some custom code and store results into the network. That's how some blockchains can be used as giant distributed computational networks, similar to SETI in some ways. For example, the Ethereum blockchain. Basic idea here is that for performing blockchain code, miner also receives a fee. The code I mentioned is called a smart contract. It's stored on the blockchain and can be accessed or interacted with by any nodes while cannot be changed. Oh, sorry. One of such blockchains, as I mentioned, is Ethereum. The Ethereum contracts can be created in a lot of ways, but the simplest one is by using the Solidity programming language, which is pretty similar to JavaScript, because it was designed to love by the web developers. So a lot of them can use it without going into the details about how Ethereum stack machine works and what is the assembly language for it. There are also a certain type of assets that base it on smart contracts. And I think you know them. They are called tokens. In case of tokens, the code of smart contracts is determine the rules, how token is created, who own them, and some rules such as transportation fees. For example, you can create a token that would signify the owning of real estate property, or a token that is mined by playing in some video games, crypto video games, for example. Or you can create a tokenized weather forecast that's connected to the actual meteo station and might only when the weather in Minsk is sunny. Which can make your token is extremely scarce because, well, there is not a lot of sun here in Minsk. You can represent real world assets as tokens and train them on the platform and they support it. But how can you connect and interact with such a diverse assets in any platform, in any platform? The most common is, there are a number of standards which provide rules for every token that's implement them. The most common is ERC20, which is basically the token definition. The most hyped nowadays are ERC721 and ERC1155, which define so-called NFT token, non-fungible tokens, which are tokens that represent some unique value, a piece of art, and flats, and a car, or a sound, or something like that. So if your platform meets the standard, you can add any tokens that implement them. Let's continue. Oh, sorry. Okay. Now I think that we learned what the blockchain is. It is clear that any blockchain integration, whether we want to learn something from blockchain, observe it, or to interact with it, would need to use so-called blockchain nodes that observe information from other nodes. That's how basically distributed copy-based database work. Of course, we can write this software by ourselves, but there is no point in it because we cannot really add any new functionality to blockchain without a global consensus. And existing nodes implements all necessary, all supported functionality right now. which can be accessed by the standard API. We'll talk about this later. Sorry. We have decided to interact with nodes via API, but should be hosted. Of course, there are commercial nodes. Well, we can either connect to the existing commercial nodes, like an Infura. I think, yeah, there it is. Like an Infura. Connection to the third-party nodes is okay for like an Infura, but connection to the third-party nodes have some limitations. For example, you will have slower speeds requests, slower speeds. You will have the limitation for the types of requests that you can do. For example, you cannot subscribe for the transactions, at least you cannot in 2018. And it's more expensive for our tasks. I would like to present the little slides. So the pros and cons of the Infura and of maintaining our own nodes. That's why we are started to maintain node locally. There are common misconceptions that you need to store the entire blockchain to run your nodes, which is hundreds of gigabytes of storage. That's not true. You could download only the parts or 1 million of blocks, for example, which is no more than 5% of the network. You need it to perform some tasks you need. If you have no need to find all historical data. And also you can request other parts of the blockchain when you actually need it. It is possible. So how this blockchain integration looks like? Mostly it looks like this. You will see the integration with the third party, and as you can see, the provider here is a provider that's made by ourselves. In our case, it's called Ethereum Blockchain Gateway. And the provider just connects to the nodes and performs some operation. I will tell about this right now. We can see 3 modules here. Let's start from the platform module as that I mentioned earlier. In general case, Wallet Manager module is a module responsible for maintaining all asset transfers. Just to remember, including the transfer control logic. In a standard client setup, Wallet Manager interacts with the third-party provider API, assuming that provider supports certain functionality. That set up the tasks. Our second module, Ethereum Blockchain Gateway, called provider here, should handle. The first task is, I think, okay. The third task is to check the status of the transactions. The second task is to create the Ethereum and the token transactions. The third task is to generate address for user based on the user ID. So we can, I will tell about this later. And also we want to find all transactions created by the platform, all transactions that made on the addresses that were made by our platform. One moment about Ethereum addresses, how Ethereum address works. You have some private key, and the address is derived from your private key. And no one can sign the transaction without your private key, and that's why only you have access to your address. And as you can imagine, if you have a lot of addresses, you will need a way to either store thousands of keys, either to derive the keys. I will tell about this in a minute. Okay. Also, of course, we need all of that for the ERC20 tokens. This was the first purpose. For retrieving all the information for okay, I will pass to the previous slide. For retrieving all this information from the blockchain, we have the third module running Open Ethereum blockchain nodes. We have chosen this node historically due to the fast synchronization speeds. It synchronizes the blockchain pretty fast. This can work in a matter of 10 minutes, I think. As you already know, the nodes, the Ethereum nodes provide a rich API to retrieve the information from blockchain. We have no need to implement this API request. This API is standard. There are official Ethereum SDK called Web3, and in our case, Java port calls Web3G, Web3 Java. So basically, it looks like this. We can execute the request by ourselves using, for example, curl. And there are examples of how we can call these API calls using the Web3 integration. All we need is to configure the Web3 where our HTTP port for node, and then we can interact with it just like with any other Java class. It's kind of cool. Okay. Implementing status checking and transaction creation is somewhat trivial, I think. We just call some requests and that's all. Also, we want to, as I said, we want to have an ability to create an address for every user deposit to be able to identify user. Every address is associated with a private key, which was used to generate the address, and we don't want to store thousands upon thousands of keys. There are a lot of ways to avoid that. We used good old Bitcoin Improvement Proposal 32, key iteration approach, and securely store the master key using the vault software. Also, we want to store all transactions in which addresses generated by us are involved. That can be achieved by subscribing to all transactions that pass through our nodes, that's all transactions from the blockchain, and storing the desired one in the database. In our case, it's Maria database, SQL base. What are the differences in case of interaction with tokens? I think you can see the slide that there are differences. For example, if we want to know the balance of the token, tokens are contracts, that they are called. So we need to interact with the contract interface. A contract is something like class in this approach. Thankfully, any contract interface can be easily generated using our Web3G. Also, the subscription process is different. In case of tokens, it's much more convenient for us not to subscribe on all transactions to the token address, but to subscribe on the events that's called logs. This is a Ethereum mechanism, blockchain mechanism, used to store contract state. Every function call that changes contract state gets written to the log that could be parsed by any number of filters. For example, if you call function balance, there will be filter to find exactly the function balance. Or for example, if you want to find the transaction, you filter by the transaction from function, transfer from function. That's kind of easy. So yeah. Of course, this is just how we implemented this integration, but there are other ways to do it. There also were some issues with our implementations. First, and the biggest issue, that's if you know, if you have to launch and maintain blockchain node locally, it's costs some processor time, and it's sorry, 1 minute. Okay. Yeah. There are problems in maintaining the nodes because it stacks up sometimes, and you should be able to restart it in a time. There can be some downtime. Okay. So that's whereabouts. Okay. So there are the conclusion about what Bear implementation gives us, and here comes the fun part. I think I remember all the issue with the private providers the third-party providers I have described. We got rid of almost all of them. And now we have no worries about the security because all the keys, or one master key, is stored on our machine. There is no problem with support because we can fix any problem in a matter of hours or at most days instead of months. We can perform any number of requests because all of the information needed is already stored in the database. And the fees, well, the only fee we are now paying is the hosting server with a node and the electricity bill. We can select the transaction fee as it's our client's needs. For example, if the client doesn't want the fastest withdrawal option, we can set a lower fee and be placed further, and it will be placed further in the transaction queue, and we will pay less, client will pay less, all will be happy. Everyone will be happy. And always work in supports is, I talked about this previously. The cool thing is now we can add any Ethereum tokens that conform to common standards in a matter of really minutes. We have no need to even restart the platform thanks to the flexibility of the platform. The clients need to provide us the information about the token, just the token address, really, and it can be added to the platform without even restarting it. It's kind of amazing. A lot of clients like it. Yeah, and that's what the bare implementation gives us. After implementing, we discover some additional features that can be assessed by interacting with bare blockchain. First of all, we can adapt our platform with different protocols to interact with the other platforms. For example, there are a lot of development protocols on the blockchain to meet the requirements of various government officials. Blockchain community is actually trying to leave behind the reputation it acquired in its infancy, which requires an anti-money laundering and know your client rule, implementations and rule. One of this protocol, or one of that implements KYC, is developed by EPAM and a group of companies. That's called OpenWasp. OpenWasp is a protocol that provides the information about the counterparties, addresses, numbers, and so on, to the trading platforms, banks, and other group of interests, while securely storing it on the blockchain by implementing a number of smart contracts. You can store lots of data in the blockchain, you just need to pay for this. And it's one of the best KYC protocols available for now. I have some experience working on it. Yeah, I also worked on the OpenWasp for a short period of time. So yeah. Also, I mentioned the non-fungible tokens. It's almost impossible to interact with them using default third-party providers like BitGo or FireBlocks. They are just don't support them. Maybe FireBlocks does, but the previous ones, the previous is not. Also, yeah, that's a picture of ERC 721, and also there can be some interest in interacting with so-called centralized exchanges. There is also no possibility to interact with them without using bare integration. What is this centralized exchanges? It's like an exchanges for the tokens, for even the cryptocurrencies, but based on the smart contracts. I think someone will tell you about it. But for now, you just need to know that if you want this, you want a bare implementation. In conclusion, base integration can be really a good way to reduce costs and add some cool features to your product. Of course, there are downsides. Now only you have responsibility and liability over what's going on your platform. But it is what crypto about, I think. It's about the idea that we have no needs in centralized services or some big bureaucracy systems that told us what we can and what we can do. Good luck, everyone. Ask questions. I hope that the provided knowledge will help you to find some comfortable solution. Long live the crypto, I think.
Hi, Edward. Thank you very much for the great presentation. And I was checking the chat session during your presentation, and there was no incoming questions so far. But until people collect their bravado and ask any questions, on the Community Z portal, you can go to the Q&A or just click on the video, extend it to your screen, and then the chat session is going to extend. So please do feel free to ask any questions. How long have you been dealing with blockchain and this technology?
For almost 3 years, I think. Mm-hmm. Can I turn off the camera now? Or?
Oh, it's better if it's on. It's better.
Okay. Yeah, for the 3 years now.
Okay. And which was your favorite project ever, where you could use this kind of technology, like
of course, the Cryptocortex. I mostly worked on the Cryptocortex.
Mm-hmm. Okay.
Yeah.
Cool.
Okay. Maybe my own little cryptocurrency called Coin. It's also very kind of fun to implement. That's my diploma project. I will finish the university tomorrow. So yeah.
Oh, tomorrow.
Yeah, tomorrow.
Wow, best of luck to you. Okay, we are almost running out of time and I see no more questions, but I do encourage the audience to reach out to Edward. His contacts are displayed on the screen, and you can also find his profile under the presenters section. As well as this whole session and recording is going to be available next week on Community Z. So I hope you will have the chance to review it. And if you have more questions, then reach out to Edward. Thank you really very much for your time, Edward, in preparing this wonderful presentation and delivering it. I hope you're going to have a very, very successful completion or accomplishment of your studies. And wish you a wonderful rest of the day.
Thank you. Oh.